for those who like to watch it later. Thank you guys for coming. I appreciate you taking the time out of your day. Hopefully today's meeting will be meaningful and useful. We're going to talk about two things today. Wade's going to run us through a little bit of just a refresher on some drafting. Noticed a couple of things as we've started our monitoring for the year, and we just want to talk about it now in case there's in case there is more of an issue. Hopefully there isn't, but anyway, so Wade's going to give us a little refresher on some venting issues. And then I really have no idea how many of you are aware, but there is a TEC Auto Test app that you can use, and so I've actually got some stuff. I pre-recorded it, but it's just kind of a walkthrough on that TEC Auto Test app. So that'll be the main topics for our discussion today. And then I just have a review of training opportunities, and then a couple of old and new business items we'll go over. Before we get into any of this stuff, does anybody out there have any questions or any other items that they'd like to see added either today to today's agenda or to the agenda of a future meeting? All right. Well, the training opportunities listed here, the top two, we've covered them before in this meeting. And then I just listed, I think most of you have attended our Weatherization 101 trainings up at the training center. Our last one, for the last 3 agencies that haven't received it, is November 14th through the 16th. So just a reminder, make sure you've got that on your calendars if you haven't attended yet. Hopefully for those who have attended, that's been useful. So is anybody aware of any other training opportunities that would be pertinent to weatherization or that would be good to let everybody else know about? I get emails about just contractor CEUs and stuff. I'm assuming if you have a contractor license, you probably get some of those emails as well. If you are the contract license holder for your agency and you're not getting any emails about those CEUs, will you send me an email, and I can, that way I'll know if I should bother forwarding any of that stuff onto this group. I don't want to bother everybody with emails that you've already gotten. So, but I just got another one 2 days ago about some continuing education put on by the Park City Housing Home Builders Association or something. So anyway, I'm not hearing any other training opportunities. On the training opportunities topic, we did discuss we talked a little bit about at the state about how many training opportunities there are this year, and I kind of asked Brad if he wanted me to encourage or discourage anybody from going to these opportunities, since we will be doing we'll be doing a training for the whole program sometime in the spring, and we'll be bringing in some national trainers for that. And anyway, his advice was, talk to your coordinators, take it under advisement. You guys know how many trainings are available, but also, if you feel like these conferences would be good for you, would help you, put together a plan with your coordinators, and if they approve it, reach out to us for that out-of-state approval, and we will approve that stuff. So hopefully that gives you any guidance you might need there. One old business item was just from last meeting. We reviewed a new ASHRAE calculator. It was a draft during the last meeting. There was a quiet consensus to go ahead and publish that, and so we have published it. It is on the IWTC website on the Resources tab, and I put it in 2 places on the Resources tab. For auditors, I try to put everything under Attachment 7. So the ASHRAE calculator, if I can see it in the list here, right there, that is the new ASHRAE calculator there. And then if you're used to finding it further down the page, it's also down, I can't remember what the other section is, but wherever it was before, it's still there as well. So I have updated that. I have had a few people reach out to me with questions as they've tried that. Has anybody tried that and had problems, or anybody had any questions about that they wanted to talk about? All right, well, if you have not started using that, I encourage you to please start using that form. My hope is that it's a little easier than the old one, that it will make your reporting and your calculating a little quicker, and it'll just help clean up your client files a little bit. So please start using that new ASHRAE calculator. The next thing is our monthly production report. I mentioned we started this last month, and just a reminder, we will be just reviewing where we're at each month as far as the weatherization production goes. With our weatherization completions, we actually have set goals for a certain number of completions each month. These goals are not simply based on your agency's total goal divided by 12. Brad asked coordinators to look at their year and kind of plan accordingly and divide up their production goals based on, when they would see excessive crisis jobs or other projects or things that may distract you from weatherization completion. So coordinators should have taken that into account when they put their monthly goals together. I'm assuming that they did all of that. So based on that, this is a comparison of what your agency, well, all of the combined agency goals, so this is the whole program, goals versus actual production. And I have 2 charts here. The one on the left is the number of completions per month. So I'm comparing, like back in July, the total combined goal for the whole program was about 32, and the total completions we actually got was 19. In August, the total goal was 42, and we only got 22. In September, I really like what I'm seeing here, that we had a goal of 42, and we almost met our goal for the whole program of 41. Over here on the right is just a running total, and this is something we got to bear in mind. So we didn't meet our goal in July, we didn't meet it in August, and we didn't quite meet it this month. So we are still behind. And so even though we almost met our goal for September, we still have a little bit of catch-up to play over the next couple of months to try and make up the stuff that we didn't accomplish in July and August. So thank you to all of those who stepped up their game in September. I think it's been fun to talk with everybody. It's been interesting to see, some of the things that you guys are doing to try and get your production numbers and stuff. So we really appreciate all of your efforts there. And for those of you who have some room to improve, please do all that you can to do that so we can get our numbers up, because we do need to meet our production goal for this year. So does anybody have any questions on this at all? All right. Well, if there is nothing else there, we will move into, I think we're moving into our main topic. Yeah. Move into our main topic. Wade, are you ready for me to share the screen with you?
Yeah, let's do the video and see if technology works.
All right. Is it giving you control on your end?
I think so. Can you guys see my screen with my mouse cursor spinning around in the middle?
Yes.
Yeah.
Okay. So what we're going to talk about today is some stuff we ran into out in the field in monitoring, or I should say Turner and Dalton have, because I haven't been out doing any monitoring yet this year. A situation that we've discovered a couple of times now, so we're just going to go over it and kind of explain what's going on. But what we run into a lot is here we have a fan-assisted Category 1 furnace. So it's a 80% furnace with an inducer motor in it. And it ties into a common vent here, and then the water heater also ties into the common vent. So if you have a CAS that gets very, very negative, which we've seen this happen a couple of times now, and this furnace fires, it's possible that while you're checking the vent pressure maybe right here in this area, that you're seeing, oh, the vent pressure is good. It's negative with reference to the CAS, so the furnace is venting and passing. But what's actually taking place is because the CAS is so negative, the flue gases are sneaking over here and spilling out of the water heater. And you can even see on the top of this water heater how corroded it is because it's been backdrafting so much. Some of the flue gases were going up the flue here, but some were still sneaking out of here. And so if you're just taking the vent pressure here and you leave it at that, oh, okay, the vent pressure is good, nothing bad is happening, you're missing what's truly going on with this, and that's flue gases are escaping out of here. The quickest and easiest way to figure this out, and we've done this, everyone who has a QCI and an auditor certification, when you took the test, we had you prove to us like 3 different ways you can tell what's going on. So who could tell me what would be one of the easiest ways when this furnace is running to know if flue gases were coming out of that draft hood?
Put your hand there and see if it's backdrafting. Put a mirror there, see if there's any condensation coming out.
Wizard stick.
Wizard stick, your hand, a mirror, okay? In the past, there's actually been auditors who have caught this problem and some other problems we'll talk about with that simple trick. Their manometer was telling them one thing, but the reality is something bad was happening, and they caught it because they just stuck their hand over there to make sure. And I've seen this happen quite a bit, especially if you have a very negative CAS, okay? Let's see if I can go to my next slide. Aha, okay. Same thing here, even in this setup, and those of you that are RMGA certified know that this is not a proper vent setup, but anyway, same scenario. So this is a fan-assisted Category 1 80% furnace. If this thing's running and you're checking your pressure here or even here, you may see, oh, it's negative with reference to the CAS. That's where it should be. I win. But again, if your CAS is very negative for whatever reasons, I've actually seen this where the flue gases will come up here, turn this corner, and this is a very sharp corner, and start spilling back out here because the CAS is so negative. And so the flue gases are going, when they reach this point here, path of least resistance is right back down here out of the water heater, okay? So we need to make sure that we understand what's going on with these, and when you see these funky flues like this, you know, be aware, be cognizant, and anytime you have a 80% fan-assisted induced draft furnace tied in with the water heater, you need to be testing this. This is part of your worst-case draft testing, okay? So you test your water heater, see what's going on with it, shut it down, let your flue cool off, and then go ahead and fire up this guy, check it, and when it's running, go ahead and come over here and just put your hand over there and make sure. Because the fan inside of this furnace is sucking air out of the CAS. And if I'm sucking air out of the CAS, I'm causing it to do what? Anybody?
It's going to depressurize the room.
It's going to depressurize it. It can cause the CAS to depressurize more, correct? Okay. So what about this cool setup here? When you see stuff like this, okay? You can actually, in this situation, even when your water heater's running and you're measuring this, you may see and I've seen this in the field. We went out and solved a problem in the field because this is what was happening. It wasn't this exact design, but something very similar. So the manometer's going negative and then positive and then negative and positive, and what's happening is because this flue is so convoluted and goofy, it would vent a little bit, and then it would backdraft a little bit, and then it would vent a little bit, and then it would backdraft a little bit, okay? Same thing here with this furnace. With this thing runs, if the CAS is very, very negative, it's possible that you're going to see a negative pressure anywhere in this vent. All of a sudden in this area, the pressures may be flipping back and forth, positive and negative. Then you come back in here and measure this pressure. This is going to be positive with reference to the CAS because everything's spilling out of the draft hood over here. Okay. Same scenario here, and you can see it again on top of this water heater, discoloration, rust. That's always a sign that there's been some backdrafting or some kind of backdrafting going on. Same deal here, a fan-assisted 80% furnace. If I measure my vent pressure here, it's probable that I will see when the furnace is running a vent pressure on the manometer that would tell me, hey, it's good, I'm winning. But what's actually happening is those flue gases are coming over here and being pulled out of the draft hood because the CAS is so negative. Even this is textbook perfect design, okay? This is right from the book. This is how you should design a good venting system. Even in this scenario, guys, if you got a CAS like that's negative 15, and we've seen it in the field, Dalton had one just the other day that was, what was it, Dalton, negative 13?
Yeah. Yep.
Yeah. A CAS that negative, even in a perfectly designed system, and I've seen it happen, flue gases will come up here, and because your CAS is so negative, it's like a vacuum cleaner, and it just starts sucking them right back out of the draft hood. And the fan that's inside of this furnace pulls its air through these louvers on the door, okay? A comment was made apparently by an auditor, well, we don't test those because they're direct vent. They have a fan in them. That is not the case. And if anyone out there is an auditor or a QCI and you do not truly understand what a direct vent appliance is, call me so that we can get you up here and teach you. I'm going to cover that here in a minute. But just because it has an inducer motor in here does not make it a direct vent appliance. And in this case, this inducer motor is sucking air out of the CAS. So when this thing fires up, it's like having another exhaust fan in this scenario. And so it can cause this CAS to go even more negative, pulling flue gases right back out of here. So when you're testing these, again, remember, so in this point, if you're firing the furnace, you might be testing here. You may see a manometer reading that says, yeah, I'm negative with reference to the CAS. Oh, I win. But over here, what's really happening is the flue gases are going up and right back out this draft hood back into the room. So again, the quickest way to figure that out is use your hand. Seen it happen before. Also, birds getting stuck in here. So an auditor one time had a bird that was stuck somewhere in this area. The manometer was telling him the flue was negative with reference to the CAS. It was a very low negative number, like negative 1.2 or something like that. But there was still flue gases spilling out of the draft hood. And so he called me. He's like, how is this possible? I said, there's got to be an obstruction in there that's letting some of the stuff sneak by, but some of it come back out. So always in conjunction with your manometer, stick your hand up there or a smoke stick or a mirror or something. Just double check. And especially when you have an 80% category 1 fan-assisted furnace sharing a common vent, and when you're running into these kinds of crazy vents, which I know you guys see every day on a regular basis, you need to be checking that, because even on this perfectly designed textbook vent, that problem can still occur with a very negative CAS, okay? So I want to talk about direct vent appliances, because just because a furnace has an inducer motor in it does not make it a direct vent appliance. A direct vent appliance, and this is the textbook right out of the Questar gas book, the definition of a direct vent appliance is appliances which are so constructed and installed that all air for combustion is derived from the outside atmosphere. Okay, so all combustion air comes from the outside. and all flue gases are discharged to the outside. And so all flue gases are discharged to the outside, and they have sealed combustion, whether it be an actual truly sealed combustion chamber or a door with a gasket that seals those burners off from the CAS. This thing can't backdraft. So if it's a direct vent appliance, a true direct vent appliance, no, you don't need to test it, okay? They won't backdraft because the CAS has no influence on them, okay? All combustion air comes from outside into the furnace, and this blower actually pressurizes the flue and blows the flue gases out, okay, on 90% furnaces. This is an 80% category 1 fan assisted, okay, so 78 to 83% efficient. The fan sucks air in from the CAS through these louvers, so it sucks air in into the burners. The products of combustion go through the heat exchanger, but this fan now does not push those flue gases out. Once the flue gases get to like 6 inches above the fan, it's a natural draft unit. It depends on the fact that hot gases are buoyant, just like a water heater, and they naturally draft up. In an 80% fan-assisted furnace, this fan is not pushing the flue gases out. It's a non-pressurized flue system, or what we call a Category 1 fan-assisted furnace. In the new Questar book on page 31, there is a definition of a Category 1 appliance, and it's an appliance that operates with a non-positive vent pressure, okay? Just like a water heater, for this thing to work, this vent has to be negative with reference to the CAS. And these things can backdraft, but when they backdraft through the inducer, through the heat exchanger, and back out the burners. And they have safety mechanisms in them to prevent that, called pressure switches and rollout switches. Because the only way this will backdraft is if it pushes the flames back out of the burner. And so the pressure switch will catch that, or the rollout switch will catch it. But the thing we've been seeing is this scenario where the flue gases are coming out of this. We've got a reading here that indicates it's good, but because the CAS is so negative, like negative 13, that they're just spilling right out here, okay? So keep that in mind. There are 80% furnaces that are direct vent. You see them all the time in mobile homes, and this is a typical mobile home furnace roof vent, okay? So the 80% furnaces you see in mobile homes, if they're a true mobile home furnace with this type of roof jack, the way this works, this is called a concentric vent. The flue gases go up this pipe in the middle here, and that middle pipe goes all the way up to the top, and the flue gases come out the top, and the combustion air is pulled in through the side here and comes down this big pipe into the furnace. And you'll notice on those 80% mobile home furnaces, they have a sealed combustion chamber. The combustion chamber is not open, okay, like this guy with louvers, or like this guy here, okay? So you can run into 80% furnaces that are direct vent, but remember the key is direct vent means that all the combustion air is pulled from the outside through some kind of pipe, not pulled from the CAS, and all the products of combustion are then vented to the outside through some kind of pipe, okay? So just because the furnace has an inducer motor in it does not make it a direct vent appliance. End of my slideshow. Are there any questions?
Hey, Wade.
Yes.
Hey, so when you're testing the furnaces, if you're testing them a foot up, you could still have a negative pressure. You're not going to see it until you get to the water heater.
Exactly. So just right here in my picture, let's say I've tested the water heater and the water heater passed just fine, okay? So I allow the flue to cool down, and I come over here and test here, and for whatever reason I've got a very negative CAS. And when this inducer motor turns on and this starts sucking air out of the CAS, it can cause my CAS to become even more negative, okay? So I may see a vent pressure here that says everything is good. So I may see negative 2.5, let's say here.
I'm saying
But the flue gases are actually going up and turning this corner and spilling back out here. So although I might see a good pressure here, or pressure that indicates I pass, if I come back over here and test, I'll see a pressure that indicates that I fell. And the quickest way to do it is just put your hand right there.
So you basically, you can't put any numbers down though in the furnace flue. You're still going to have to check it in the water heater flue. Correct?
The point I'm trying to make is when you run into these, don't rely just on that number alone, and especially if your CAS is very negative, okay? And that's the situation that we ran into on some of these things that we've recently seen. Yes, we still need to record these numbers and do our, our paperwork and stuff, but when you're running into these situations where you're going to leave an 80% fan-assisted furnace in and maybe just tune it up or whatever, or, whatever the case may be, when you're checking this, just be cognizant, especially if the CAS is negative, like negative 13 we saw the other day. The other one was negative 9.5. And this is exactly what we saw in the field is, yeah, things were good here. And so someone decided, okay, we're good. The numbers are good. And because there's no draft hood on here to hold your hand over, they figured, okay, we're good. What in reality was happening were the flue gases were being sucked out over here because the CAS was so negative. And had they just taken the time to hold their hand there or come back over here and check this pressure, they would have seen there was a problem. Alternatively, I suppose you could just leave your probe here, check this system, and then check this system and see what's happening. Because if you see a positive pressure back here, you know that something's spilling out of that draft hood.
That's kind of what I was trying to get at, because if you could get a false reading here, wouldn't it just be better to check it here to see?
Absolutely. I mean, you could just make one hole here and leave your probe there and know, what's going on. You will see the positive pressure happen here because here's your outlet. Here's where it's going to escape. Okay.
Right.
I just want everyone needs to know what goes on and what I have seen in the field. And even if you come and check up here, you may see this weird thing where it bounces back and forth, negative, positive, negative, positive, negative, positive, because some of the flue gases might escape a little bit, and then they start shooting back this way, like the very first picture I showed. That's exactly what was happening. Some was going up here, and some was coming out here, okay? Test here, you'll see a negative number. Test here, you'll see things bouncing around doing weird things. Test here, you might see 0 or, negative 0.2, but the kicker was, obvious. Whenever you see rust and discoloration on top of a water heater, it's been backdrafting. And the way that the problem was found was someone stuck the back of their hand over there because they saw all the corrosion and went, something's going on, something's not right. And it's kind of like I always say, we've got to be detectives when we get out there. So we just want to make sure that you guys understand this scenario and how that can play out. And again, the takeaway from this is if you're seeing really negative CAS and you've got a Category 1 fan-assisted furnace sharing a common vent with the water heater, when you fire and test this furnace, come back and check this real quick with the back of your hand, or like Tony said, just leave your probe right there. That'll give you a pretty quick clue what's going on.
If you only put a probe in on the water heater and you're doing your worst case on the furnace, I think you're going to get a lower reading. Even if that whole vent is negative, and it's all venting properly, I think your vent from the furnace would be stronger in the furnace flue than it would be in the water heater flue, wouldn't it?
Typically, yes.
So you definitely want to test both places, because if you were only testing at the water heater and you were testing the furnace, you may not meet the minimum acceptable draft.
And that is true. And the other thing you guys need to know about these furnaces, if this furnace, because of the safety devices built into it, ever saw a pressure anywhere in here that was positive with reference to the CAS, that's what the pressure switch is there for. It will tell the system I need to shut down. It will protect itself. But the problem that we've seen is The pressure switch is seeing that, oh, the flue is working properly because this is a nice negative pressure, but the problem is the flue gets to this point, flue gases get to this point, now they have a decision to make. And because the CAS is so negative, the decision is, let's go this way instead of out this way. And that's what we've seen happen a couple of times. So just be cognizant of this. And also, again, like I said, someone mentioned, well, we don't test these because it has an inducer motor in it. That makes it a direct vent appliance. That does not make it a direct vent appliance. A direct vent appliance, again, is an appliance where all the combustion air comes from the outside, has a sealed combustion chamber, whether it's this setup or a door, and all the flue gases go to the outside. And even mobile homes have direct vent 80% efficient furnaces in them. We run into those out there, so you just need to be aware of that, okay? So direct vent means there's two pipes of some sort, and they both go directly to the outside. Any other questions? And if any of you have questions that you don't want to ask here, you can call or email me. I'm happy to work with any of you if you have questions about furnaces and furnace identification.
Thanks, Wade. I appreciate that.
Thank you.
I came across one recently, and this was, we kind of ran into 3 or 4 different things, and they all started pointing this direction. That's why Wade has reviewed this stuff. But one of the things I saw was that somebody had checked the box that, you know, it was all combustion appliances are direct vented, and in that particular house it was not a direct vent appliance. So the form is not perfect. It will not cover every single scenario, and that's why we have a section for notes down here. The form's not always going to tell you the answer that you're after. So as Wade was saying, like you do have to be the detective. You have to sometimes go the extra mile when things are just not adding up. So watch for some of those things when we're out there.
And if you run into them and you're having troubles figuring them out, call us. That's why we're here.
Yeah.
We're here to help you guys, help make your job hopefully easier and better. So if you run into them, call us. We will come in the field and help you whenever we can.
Yeah, that's one of the situations we've run into is just that. When an agency called us, and we're happy to go out and see what's going on. It's way funner than staring at my computer all day. So give us a call. All right. If there aren't any other questions on that one, we'll move to the other part of our training today. Is there anybody out there, have you guys been using this TEC? It's called TEC Auto Test. It's an application you can download on your iPad or your iPhone. Has anybody been using it? Go ahead.
Matt, I'm sorry. I just got one quick question. I've been trying to use your ASRAE form, and it works like half of the time.
Okay.
It's just not giving me a number. So I've been checking it with the old one, and it's like, it just won't. So like I just did one, and it's not calling for anything. Like the CFM boxes on the bottom just kind of disappear after you put the numbers in it. And then it sometimes it gives me a number that I could use, and I test, and it's like 1 CFM off. And like the last one I just did, it's not giving me nothing, and it's calling for 64 continuous. So I'm kind of happy. I'm sorry, I didn't mean to kind of go off track.
No, that's I appreciate you mentioning that. I will call you probably after this meeting, and let's work through that. And for anybody else, if you're running into issues with that form, let me know. I've had a few questions come up, but so far we've been able to work through them all. But yeah, please, when you're, I don't want to give you something that's causing you problems or it's not working. So let me know. But yeah, I'll give you a call after this meeting, if that'll work, Tony. Thanks, man.
Thank you.
All right. Anybody using this application yet out there? Well, if you are not, so if you read our guidelines, right now the guidelines say you have to use the TEC software. And the TEC software is the stuff you download onto a desktop computer and you run that. So I am hereby giving everybody permission to use this application or the TEC software. It's made by the same company. The TEC part is the Energy Conservatory. Those are the folks that make and sell all of the blower door and duct blaster stuff that we use for the most part in our program. And this software works very well with it. So if you haven't tried it, I would encourage you, if you have an iPhone or an iPad, download it. But I'm going to walk through and just show you some of how it works, some of the features of it. Hopefully you'll see something useful. I think this is a lot faster than the desktop stuff, so that's why I wanted to share it with you guys. I did reach out to the Energy Conservatory with a few questions, and I did ask them about an Android version. They are working on the Android version, but I think they released this iPad Apple version just a couple of months ago. But it works pretty good. So I pre-recorded this. I'm going to, in this video, I do a multi-point duct blaster test, a single-point duct blaster test, and we do a whole home leakage or a whole duct leakage, and a duct leakage to the outside test. So it's kind of, here's the application and how it works, and also a good review of how to do all of these tests. It's pre-recorded. If you have questions while it's going on, if you'll type them into the chat, and then we'll take a few minutes at the end to answer those questions. This video is 27 minutes long. So that tells me we are going to go a little over on time. If you need to drop off of the call, we're recording this. You can watch this later. But anyway, yeah, I'll kind of field questions in the chat while it's going. Can you guys let me know as soon as the volume starts? Can you guys hear the volume on the video?
I cannot hear the volume.
Yeah, I got nothing either.
Nobody can hear the volume. Let me see.
What's that thing? What's that meter they're using?
That I had to check it out at the museum. It's called a DG700. It's kind of old. Let's see. Speakers, headphones. Let me just see if I can switch. Let me hit play again. Let's see if this is working.
Yeah, iPhone tablet or iPhone.
Now I can hear the volume.
So
Okay.
basically, all you got to do is I have the Wi-Fi module on top here. So you just plug that in and turn on your DG700, and that's it. You don't touch anything else on the DG700. You do have to click the fan on, and then you want the cord for the cruise control set up. And that's it. I've got my blower door set up with the cover on, and we're going to come over here and we're going to go to the iPad, and we're going to run through the settings on the iPad. Okay, on the iPad, the first thing you've got to do is just go into your settings and change your Wi-Fi, or point your Wi-Fi at the DG700. So just select that. If you haven't put a password in lately, it'll ask you to put that in. And then once you've done that, now you're ready to go in and run your TEC Auto Test. So first thing you do is you get to create a new project. So I just hit plus, and I'm going to use my little wireless keyboard, so you won't really, I'm doing that off screen. But let's just go October 2017 technical meeting. And I hit OK. And then this is one of the things that I think will help make things quicker. There's there's a button here, and if you have your location turned on your phone, you can click the button, and the button will determine your location. It grabs a latitude, a longitude, and then you just select use current location. And then you'll see in a minute it grabs the altitude which you need. So if you do that for your building, and then sometimes it will ask you if you want to use the local address that it's found. In fact, so if I say use current location, anyway, if it can find an address, it'll just say, do you want us to use that address? And then you can also put in the name of the customer, which is nice. We'll say, you know, Bob Vila is our customer today. And you can put in more information if you need to, but that should do for right now. You can always go back and edit that stuff. And then down below it says tests, and you can edit any of your tests, or you can hit the plus sign to create a new one. So the purpose of this test is going to be a blower door, and I'm showing an example of the DG700, so I'm going to say blower door DG700. If you're auditing a home, you could put, you know, pre-weatherization blower door or blower door audit or whatever you want to do. There's a few options here. You've got to select one of them. The IECC 1215 envelope leakage is probably the best one. It's going to be the most accurate, but you can also just do a CFM 50 envelope leakage. And this is the multi-point, the ICC one, and the CFM 50 is just the single point blower door test. So I'm going to select the multi-point test. Again, you have the option to set a leakage target in air changes per hour of 50. You can set all kinds of things here. You can put in your building volume, your surface area. In fact, if we put that stuff in, and I'll show it on another test, it will actually calculate air changes per hour properly. But you can also just leave it all blank, because for our blower door, we really don't need all of that stuff. And then the first thing you got to watch for is just up here, it says gauge, and you just have to click connect. So now, since I got my Wi-Fi module on, we've connected to the DG700, and it's showing this graph because it's going to run that multi-point test. If you click start test, it asks for your indoor and outdoor temperature. Our indoor temperature this morning is about 68 degrees. Our outdoor temperature is 65. And then if you didn't push that use location button, then the altitude section will be blank and you'll have to look up your altitude. But since we already selected that, it has populated that and it's ready to run the test. So, and then it says just exactly what you're used to on the TEC software. We'll do a baseline for you. With the cover on, it takes a 10-second sampling. And it just tells you up here it's measuring the baseline. And then since the baseline's done, go ahead and uncover things. So we'll uncover our fan. And we're going to take all of the rings off so we have an open fan. So when I hit continue, it asks me which ring setup I have. I'm going to select open fan and leave that. And then it will just automatically start running the test. Okay, it's telling me I need to put a new ring on. So I'll come over here and put ring A on. Hit continue. And then once it's done, we have to do another baseline. So we cover it back up. continue. And this asks for the indoor and outdoor temperature one more time as well. So we're still at 68 degrees and 65 outside. And then it says the test is complete. Would you like to view the report? Okay, and then it shows us what the test is. Again, the multi-point blower door test, it takes multiple samples at different pressures and averages them all together, so you get a more accurate measurement, but it also does take a little more time. You're not required to do the multi-point, but you can. And then this test, the results, the way that they've set this up, it's for the IECC, which you're looking for air changes per hour. And so you have a measured leakage and a target leakage and whether or not you pass. It's saying 0 because we didn't put in our building volume. So the results here and the pass here really mean nothing to us. But in weatherization, this is what we're looking for here is what we measured at CFM 50. So this house had 3383.7. So that was our blower door number off of this one. So the cool thing is, so we did put our building volume and our surface area in earlier. If you'll come back in here, you can do that very quickly. So our volume is 9506, and our enclosed surface area is 1162. And you can also make any comments that you want to if you needed to add something. But you still have all that same data in here, but now it's going to show the report. And it's saying that our measured leakage is at 21 air changes per hour based on that surface area and volume of a building, and that we failed. So you can see we still have our original blower door numbers, but now we've got our building volume and our flow coefficient and things like that are all laid out. So it'll keep the test results, and you can modify this test. You can also go back and modify and put, if you didn't know what the client's name was when you were in the field, or you didn't know what their address was, you can go in and change any of that, and then generate that report. So now we have a project ID for October 2017, and we have a blower door DG700. And what I want to do, I'm actually going to edit the title of that. So instead of saying blower door DG700, I want to put multi-point. So this is our multi-point blower door DG700. So, oh, whoops, I added one named multi-point. That's not what I wanted to do. Let's edit and throw that one in the garbage. We're going to go into the blower door, and we're going to change the name of it. Sorry. So multi-point blower door DG700. Okay, so now I've renamed it. Now I'm going to run another blower door, and this time we're going to do a single point. So I'm going to add one. But before I do this, what I want to do is I actually want to change out my gauge. Okay, so we're going to swap this out for the DG1000 instead of the 700. The DG1000, I'm really liking this. The setup on it's a lot easier. So I just held this power button down, and while that's powering up, I'm going to turn this off real quick, and we're going to disconnect this. And one of the things I dislike about the DG700 is you have to unplug your Wi-Fi, or it will drain your battery. But okay, so I'm going to take this down, and okay, I swapped out the this mounting bracket for the DG1000 mounting bracket. I like to put in a couple of grooves here to hold your hoses, and then also it's just magnetic, so all you got to do is slap your gauge up there and it stays. And then the other nice thing is, so we're going to go to gauge. All your ports are down here, but so we're going to put in our input and our reference lines, right? So on channel A, we're taking our input is the building pressure, and our reference point is the green hose, which goes outside. So we're referencing inside right here to the outside. And then on channel B, our input is actually the pressure from the fan. So we're going to put our red hose on right there, and then we're referencing our indoor pressure on this tab. So this should be our setup for a blower door. And you do have to connect one thing. You got to plug in your cruise control. That just goes right in on top of the gauge here. But other than that, the Wi-Fi is running, so we'll just switch this back on. And then we'll come over to our tablet. And so all you got to do is slap your gauge up there. And you do have to connect one thing. You got to plug at 950.
Sorry about that. I didn't get a chance to review what I put together. I obviously put in the wrong chunk of video there.
1000. So for our single point, we're going to select just a CFM 50 envelope leakage and hit, 50 and hit OK. And one thing I didn't show you, you can put in your name, so you can put in the technician's name, credentials, your email, stuff like that, and all of that stuff will show up on your report as well. Again, you can change your building volume and things like that. So let's go ahead and put in the same building volume at 9506. And our area is 1162. And we're going to go ahead and run the test. So here it says the gauge and we need to connect. So you just click connect and it grabbed the DG1000 and it is monitoring. So now we're ready to start the test. So you can see all we're going to do is we're going to take a baseline. We're going to take one measurement at 50. So again, it asks us for our indoor and outdoor temperatures. And since I already did a geotag on it, we know what our altitude is. So it says, are you ready for your baseline? And with the cover on, we are ready for the baseline test. So we run that. And it just takes a 10-second sampling. And then we uncover or put whatever ring we want on for our test. In this case, at 50 Pascal with this much leakage, we're going to have it open. So we hit continue. Open fan, okay. Run our single point test. And on the single point test, you don't have to put the temperature back in or anything like that. It just says, would you like to view the report? Hit yes. And you can see that we put in all the same stuff. On this report, we're really just after the measured leakage. So it tells us right here we were at 3581. Slightly different results from what we got off the multi-point test. The multi-point test will give you a lot more information, or is a lot more accurate, but the single point test is sufficient for what we're doing in our program. So when you're done, you can get back in here and you now have on your iPad, you've got your customer's name or your project name, and you can see all of the tests that you've run for that customer. Okay, I've got the duct blaster set up, and I'm using my DG1000, and we're going to do a total duct leakage test. So I've got a couple of doors open to the outside, this one and that one, and then I just have every one of my registers all sealed off throughout the house. Once we have everything set up, we're going to go ahead and run our test from the tablet. We just need to select our October technical meeting. It shows that we have our 2 blower door tests already done, and we're just going to add a test to it. The purpose of this test is going to be total duct leakage. So I'm going to give it that name, and you may also want to include like pre-weatherization or something. And then if you'll select your CFM at 25, duct leakage, hit OK. And then the other variable here is the condition floor, which is 1304. Not really sure why that plays in, but we'll enter that. And then it takes you into the test. Remember, every time you gotta hit connect to your gauge. And once it finds the gauge, then you're ready to run the test. The other options, you can switch to a different type of duct blaster, but basically both the older white housing fans we have and the black housing fans, the newer ones, both of those you're just going to select Duct Blaster B. And then you have your configuration over here, but you'll notice when you start the test, it's going to check and make sure that you thought about your configuration. It makes you verify what that is. So you just start the test, hit whatever you're configured at. Here we're at an open fan. And then the fan will slowly ramp up. You can see over here on the left, it's slowly ramping up to get the duct pressure up to 25 Pascal. As soon as it gets close to 25 and actually can take a decent sampling, then the test is over. But you'll notice until we get up to a decent steady pressure, then it's saying low. Now we're starting to read some flow on the right-hand side. Get the sampling, and the test is complete. You hit yes, you can see the report, and it's just got all the general information we put in here, and really all we're looking for here is that the total leakage was 644.9 CFM. So that's it, and when you're done, you can get back into this project, and now we have all 3 of our tests in there. Okay, in this test, we are going to do our duct leakage to the outside. So we have our blower door, we've turned it around, and we just have, using the DG700, we've got it set on cruise control at 25 Pascal. So it's pressurizing the house to 25 Pascal. We have our duct blaster set up in here, and we're using the DG1000 to run our duct blaster. So the duct blaster set, you put the dial just down here so it's just barely on, and that way we can run it remotely. If you turn it up at all, it'll run the fan speed, but it won't do the cruise control. So you gotta leave that there. And then as soon as we connect, we'll run all this remotely. But one of the things you've got to do, if you're going to use the software to run your duct leakage to the outside test, you have to reference the outside. So on this port, input A, that's our duct pressure. So we're running from right here, right up into our duct, just above, into the supply side of the duct, just above the air conditioner. And then channel B, we're going to measure our flow going through our fan. So that's why the red hose is going down to the fan. But if you're used to doing this test, normally you're gonna leave this port open, and you're gonna run your fan speed to 0 Pascal of pressure. But the software that we have does not have that option. It'll only go to 25. So in order to do that, you have to reference the outside pressure. So this blue hose runs outside the building envelope. So when we run our fan, we'll actually run our fan up to 25 Pascal of pressure, which is the exact same as if we took this off and ran it to 0, and it would be referencing this inside space. So we've got everything set up properly. Now we're just going to go and run it using the iPad. Okay, so we got the blower door fan running. Hopefully that's not making too much noise, but on this one, we've got our project selected, and we're just going to go in. We're going to add one more test. This test we're going to call duct leakage to the outside. And again, you may want to go pre-weatherization or something like that. And then you have a few options here. Every single one of them will only do the test at 25 Pascal. So you've got the IECC, you got a California Title 24, and then just at CFM 25 duct leakage. So I'm going to select this one. They'll all pretty much do the same thing, but try them out. The main idea is that we're going to be using 25 Pascal pressure. We're going to put in our conditioned floor space, which is 1304, and then we're ready to run the test. We've got to connect to our gauge, and we're using our duct blaster and our configuration on this one. We're going to run this with ring number 1 on it. So when I start the test, it's going to ask me what my configuration is. I select ring number 1. And then you'll notice both on the DG1000 gauge and also here, if you want to ramp that fan speed up, just slide it over and it'll jump right up for you. So that can save you a little bit of time. And then once we get our duct pressure right at about 25 Pascal, it will take a sampling and the test is complete. And here's our report. And that's it. That's all you got to do. To finish up, just the thing that I really like about this is it basically has created a folder with your client name on it, and you have all of your tests in here. And if you forgot to put in some info that is part of the calculation on any one of these tests, you can always go in and edit them because you've already measured that. But that way you can clean up your tests once you're done so that you have all the info that you want. And then you can send any one of these to yourself just by getting into the report and then emailing it to yourself. So it's not bad. Basically, it's just doing exactly the same thing the TEC was doing. Just doing it all on your tablet or your phone and kind of keeping it a little more organized, a little easier to use. All right, that was it. Again, sorry we went over a few minutes. Anybody have any questions or concerns or anything they thought of while we were watching that? I heard a little noise, but I didn't hear any voices, so I'm going to take that as a no. I would encourage you guys to try that out if you can. For any coordinators that are on the call, if your auditors and your QCIs do not have the Wi-Fi setups for their meters, for their manometers, I would encourage you to look at purchasing some. They really do cut down on the amount of time it takes on the job. The DG700s that you guys do currently have, they still work great. I think the Wi-Fi module for them is a couple $100. It's a little cumbersome. It's not as smooth as the new gauge. And then the Energy Conservatory, basically they said they will continue to service the DG700s for the next, as long as they can, but I guess one of the suppliers for some of the parts inside the DG700s has gone out of business, so they can no longer get those parts. So once those parts are gone, then that meter will become obsolete. They kind of anticipate that happening in the next 3 to 5 years or something. So anyway, thank you guys. We'll go ahead and end. If anybody has any questions or anything that we didn't get to talk about here, you're welcome to call or email. And have a great day. We'll talk to you later.
Thanks, Matt.
Thanks, Matt.